When we add or subtract algebra fractions, just like with number fractions, we need to observe if we have the same denominators. If not, we need to create a common multiple of the denominators in equivalent fractions. So for my first fraction, which is equal to 2x plus 3 over the 5, I multiply the 5 by 4, and I do the same to my numerator. Minus my second fraction, which is x minus 1 over 4. I multiply my 4 by 5, and I do the same to my numerator. Expanding these two brackets, 4 times 2x is 8x, 4 times plus 3 is plus 12 over 20, minus 5 times x is 5x, 5 times minus 1 is minus 5 over 20. Same denominators, I can now subtract the numerators, so 8x plus 12 minus the whole of that numerator, so I put it in brackets, over the common denominator, which is 20, equals, expand that bracket, 8x plus 12, minus 1 times 5x is minus 5x, minus 1 times minus 5 is plus 5, over the common denominator of 20. Collecting the terms in the numerator, 8x minus 5x is 3x, plus 12 and plus 5 is plus 17, over the 20. And we are done. On the right hand side I have an equation. In that equation I have the same two fractions subtracted as I have on the left hand side here. If I were to process those two fractions in exactly the same way, I would end up with the 3x plus 17 over 20. So I am going to replace those two fractions subtracted with the 3x plus 17 over 20. So 3x plus 17 over 20, that equals the 1. If I now multiply both sides by 20 to get rid of the divide by 20, I get 3x plus 17 equals the 20. If I now subtract 17 from both sides, I am left with 3x equals 20 minus 17, which is 3. If I now divide both sides by 3, I get x equals 1. To test I have the right solution, I substitute my x equals 1 in the original equation. Wherever x appears, I replace it with 1. So the left hand side equals 2 times by the 1 plus 3 over the 5 minus the 1 minus 1 over 4, which equals 2 times 1 is 2 plus 3 over 5 minus 1 minus 1 is 0 over 4 equals 2 plus 3 is 5 over 5 minus 0 over 4 is 0, and 5 over 5 is 1, minus 0 is just 1, which equals to the right hand side. Therefore I have the right solution.